IEEE Endasan Institute of Technology. Today, we all have gathered here for the 76th webinar as part of the weekly webinar series organized by IEEE Malabar Subsection in association with IEEE Malabar Hub and IEEE SB Endasan Institute of Technology. The webinar is on artificial neural networks for system modeling. Now, let me introduce our distinguished speaker for the day, Dr. M.V. Rajesh Maliekal. Dr. Rajesh is working as Associate Professor in the Department of Electronics Engineering at College of Engineering, Chengannur, Kerala. He is the Chairman of IEEE Signal Processing Society, Kerala Section, Vice Chairman of IEEE Kochi Subsection, and Vice Chairman of Institution of Electronics and Telecommunication Engineers, Kochi Center, with the charges of IEEE Students Forum. Dr. Rajesh graduated from Model Engineering College, Trikakara. He completed BTech in Electronics Engineering during 1990 to 1994. He completed post-graduation in Electrical Instrumentation and Control from National Institute of Technology, Calicut during 2000 to 2002. His PhD was in Intelligent Signal Processing from the Cochin University of Science and Technology, which he completed in the year 2011. His PhD thesis was in development and evaluation of blind identification techniques for nonlinear systems. His area of interest include digital signal processing, artificial neural networks, fuzzy logic, and nonlinear system analysis and modeling. Dr. Rajesh is currently the Chairman of Nomination Committee, Computer Society of India, Kochi Chapter, an invited member of Staff Promotion Committee of Technical Officers, DRDO member, Expert Visiting Committee of AICTE, Academic Auditor, APJ Kalam Technological University, member of Doctoral Committee of various universities, including APGA KTU, Kerala, and Anna University, Tamil Nadu. Distinguished Lecturer of the IEEE Kerala Section, Departmental Advisory Board, St. Gibbs College of Engineering and Technology, Kerala member, Board of Studies, Rajagiri College of Social Sciences, Technical Consultant, Think Palm Technological Private Limited, Kochi. Representative of the National Testing Agency for Examinations, including NEET and JEEE. I would like to stress that this list is highly incomplete. Dr. Rajesh has published 23 papers in international and national conferences. He is a life member of Institution of Engineers India, Fellow of Institution of Electronics and Telecommunication Engineers, life member of Computer Society of India, life member of Indian Society for Technical Education. I'm deeply honored to welcome you, sir. Over to you.
Thank you very much. It's always a pleasure to be in the IEEE community. And I would like to very sincerely, first of all, congratulate my entire colleagues of students and professors and other volunteers in Malabar Subsection for having tirelessly webinar series. And I think this is the 76th seminar series. It is amazingly a stunning performance. And in fact, Kochi is looking forward to Malabar Subsection on their activities. So we couldn't, frankly, organize that much programs, I think, in Kochi also. So it's a matter of joy for all of us. And my special thanks to Professor Suraj and Professor Sabrik and all others to how we are interacting with the community today. It's not strange to be in an IEEE community, but especially in the midst of the college opening and all the challenges that we are currently facing. It is good to see that we have this much of people sitting together. And just before going to the topic assigned, it's actually a discussion on artificial neural networks, being a topic with a little bit of mathematical content and signal processing content, which generally people hesitate to approach. My plan for today is not to go into the mathematical details as such, but to give a taste and to give an overview of the topic so that some of you might develop some interest on this And later, of course, when you go for further developing some kind of a system or a project, obviously we can keep the networking. Being in IEEE means we will be connected forever. And obviously, I can assist you remotely also if somebody is genuinely interested in doing some work. So today's discussion will be some experience sharing from my part on the artificial neural network paradigm. And then, of course, some of the applications, especially to the modeling side. That's what we have decided for today. What modeling is and what's the meaning of that, etc. will be discussed. And I understand that this is a mixed crowd with both electrical, computer, and people with some other backgrounds as well. Therefore, the discussions will be very general. And of course, I have a set of a few slides, and I won't be making it too boring. And one-sided also. It's not a simplex communication, a radio communication. I request people to interact in between so that, of course, we will make it live, because that has become the very important challenge of online sessions. There is no guarantee that people are listening. You can sign in, put your chair in front of the system and escape, right? That is a big convenience as well as a big challenge. Therefore, I request maximum number of people to interact as well. And okay, as of now, my screen is faceless, except me, no other video I could see. And I think in between, in the Olympias, as usual, we'll arrange a photo session where we could meet each other as well. So with this introduction, and once again, congratulating one and all, let me get into the business of discussing artificial neural networks. And of course, while I share my slides, I think I can turn off my video as well, because the slides are more handsome than me. That's what I would like to see. Okay, so I'll be just keeping my video off, trying to share the screen. And I request some of my IEEE student volunteers or somebody else to just help me okay, just to see that technology is working properly. So let me directly therefore go to the screen share. Okay, now I think I'll share it. Please tell me whether it is visible. Somebody, if could help me in that, that's good.
Yes,
is
sir.
it visible? Okay, the beautiful, I mean, poster designed by some of you is seen, right? Okay, and a clock is also there, so that it will remind me on how the time is progressing, so that I can appropriately close it without much disturbing you. That is my plan. So in between, for making the interaction meaningful, I have given my mobile number over there. I request the participants to just note down it. You may not be using it, but okay, just have it with you. Sometimes I request you to send some WhatsApp messages during the discussion, just to see that you are getting this point. It's not a surprise or a surprise test or examination, but point to discuss. Where if you could get it in WhatsApp, of course, I can just look into that and handle it accordingly. So I request you to just note down this. Okay, all of you may not be interacting and sending WhatsApp messages, but if you feel like that, or in between the discussion, we may just make use of that facility. So please note down my number as 9447 464687. So that is one thing I would like to request to the listeners. Now, moving to artificial neural networks, I think all of you will readily agree if I write a statement like this. All of you will agree, I'm sure. Computers are very powerful. Very powerful, right? Computers are very powerful. All of you will agree. Nobody may deny this statement, I think. And not only powerful, nowadays, those computers are very smart as well. Because of the advancement in technology, all the devices around us has become very, very smart, or sometimes even over smart. Our computer is very smart. Our mobile phone is basically over smart. And even the government is saying that classrooms should also be very smart. So probably other than some of us, everything around us has become very smart. Obviously because of this AI and the ANN, etc. I'm coming to that. But anyway, things are very smart. Computers are very powerful. This is one statement. And another kind of a possible statement is, which again, all of you will agree, is human brain is a computer. That is another statement. Human brain is a computer. So I'm trying to avoid PPT to the possible extent to at least have a feeling of interactive, interaction. That is why I think you can, bear with me, even though my handwriting looks poor, this makes more sense, I think. Okay, human brain is a computer. This is statement number 1. This is statement number 2. All these two, if you look independently, all of you will agree, I'm sure. My question is, now here I may probably require your help. Either you can turn on your mic and say the answers. That will be better if you could do that. Otherwise, in the chat, you can type in. WhatsApp, I will tell you when we will use. Human brain is a computer. Now, the question here is based on 1 and 2. This is the contest I am making. And based on 1 and 2, my question is, which among 1 and 2 is the best computer? Which is the best computer is the question.
Human brain is the best computer.
Okay, we will go for voting, I think. Which is the best computer? Is one answer is, okay, human brain is the best computer. So 1 vote for human brain. I don't know whether we get some vote for the machine. Okay, anyway, 1 vote we got from, who was proposing this? If you could say your name also, that is interesting, that's all.
Srijit Ajit Kumar.
Srijit, okay, thank you, Srijit. You believe in human brain, very good, excellent. Then who else? I request people to make some opinion, just because we may not sleep after the busy schedule of the daytime, just to see that we are live. Okay, Srijit is of the opinion that human brain is better, a computer, compared to the machine. Anybody else? Okay, something is human brain. Oh, okay, in Malabar, most of the people are more humanitarian in their approach, I think. Okay, advancing technology for humanity is our slogan in IEEE, right? So that may be one reason, I think. Professor Suraj and Sabik might have taught this to the kids, I think. Okay, anyway, nobody is supporting machine, I think, basically. But if some question like this is asked, 585 divided by 39, I think your computer will be doing it better and faster than your human brain. When you start doing it with pen and paper, it will take a lot of time. Am I right in that? But your computer will do it in 0 time, I would like to say, or within a very fraction of a second or something like that. So if you compare in that aspect of this numerical computational task, actually the machine is better, right? Then of course arguments can come like this. Even this machine is designed by the human brain, then how can we argue that the computer is better than human brain? So many things are there. So many scopes of discussing and arguing with each other is possible. But anyway, basically a comparison of this kind may not be good, I think. Basically, there are certain mistakes. My point here is, even though your machine is something like this, very faster in mathematical computations, etc., human brain as a computer has got very special and interesting characteristics. And you know, in certain aspects, which we are going to just see, human brain is much better than our machine, or there are certain features in the human brain which are worth imitating in a general sense, because it's very smart in doing certain applications or certain tasks. For example, suppose you are meeting with your classmate after, say, 20 years, etc., of leaving from the school or college. And there may be, this is an example, and there may be a lot of differences in his appearances. Sometimes hair loss, which is happened to me. Otherwise, I was very handsome, I think. Otherwise, some changes, etc. So even with all these changes, when you meet with your friend after a long time, immediately within a fraction of a second, you will be identifying that, oh, this is Shivaramakrishnan studied in the school, in the class, etc. Immediately you will hug him and identify him. Okay, because of Corona, it may not be possible. But anyway, you could identify him. But if he is himself presenting before the college gate and if the security camera is taking his picture and comparing with the database picture, which is used to make his identity card at that time, he may not be given permission to enter because there is no match. There are difficulties for the computer to identify that. But the human brain can identify or recognize the person. This is actually called feature extraction capability of the human brain. Feature extraction. You are identifying this person not only from the hair or that thing, but actually some feature of this guy is embedded in your brain. That may be sometimes a length of the nose, beauty of the smile, something like that. Some features may be there within your brain, and that is why you are able to recognize this person. And this particular capability or the feature of the human brain is helpful in many, problems like this could be, classified as a pattern or photograph identification problem. So basically we can say that human brain as a computer can process corrupted or incomplete data. That is one thing. Corrupted or incomplete data could be very easily processed. Corrupted means the current photograph and the previous photograph, which is available in the college databases, they're different. But the second or the current database can be treated as a corrupted version of the original one or something like that, or incomplete kind of a data it is. Even that could be processed by the human brain. So it is called feature extraction or pattern recognition capability, which a conventional computer system may not have. When it tried to have a lookup table kind of a comparison, this becomes mission impossible for the machine. Therefore, in certain aspects, the human brain is a much better computer than a conventional, a machine that we design and call as a computer. This is the motivation by which we are trying to imitate these good behaviors of the human brain. And the artificial neural network basically is an attempt, ANN is an attempt to imitate the behavior of the human brain, in short. That's why it is called artificial neural network. This is because human brain, again, little bit of biology, don't ask me very tough questions on this, but I can tell you that human brain, if you study about human brain, it is actually a collection of billions of single processing units called neurons. Those who have studied little bit of biology in their +2 classes knows that human brain consists of billions of neurons. And these neurons are actually, each of them, if I represent each neuron as a circle, if they are all neurons, billions of such neurons are there to form the human brain. And each of these neurons are called a processing element. Each of them are a processing element. It is just like a system with multiple CPUs. You might have heard about systems like that, a main processor and a coprocessor, etc. But in a human brain, billions of processing units or elements are there. Each of them are called one neuron. Therefore, the collection of such neurons is the human brain. And therefore, biological scientists generally explain the human brain, as a collection of neurons, or it is also called a massively parallel kind of a processing system. Massively parallel because billions of neurons arranged in a massively parallel kind of a connection, a network, and therefore human brain is treated as a neural network itself. Collection of neurons are called neural networks. It's called the biological neural network, therefore, biological neural network. And of course, we can analyze the behavior of human brain and see how it is working, etc. And then if you study some basics about this human brain as a computer with the processing elements. So when we use these words, processing elements, massively parallel, etc., we are actually converting the biology kind of the concept into our engineering or mathematical concept. Therefore, in a blind kind of an approach or an oversimplified kind of an approach, we can say that human brain is a neural network, a biological neural network. Okay. Therefore, if you have some ideas on this neural network, biological neural networks, then of course, we can try to imitate some of the activities of the human brain in our conventional computer machine itself. Then that is called artificial neural network. Funny part of this is human brain as a computer is better in some respects, and we are trying to imitate the human brain. It is called artificial neural network, but that entire stuff is done on a conventional computing machine. That is the, I mean, what I should say, funny part of that. Even though we are saying that human brain is better than the computer in certain aspects, the same attempt of imitating the human brain is done on a conventional computer. Okay, machine is therefore necessary for us to proceed with. So this is the background or the motivation by which we are moving from biological neural network to artificial neural network. When we embed the features of the human brain to a computer, it is called artificial neural network. Otherwise, when it is part of a human being, it is of course the biological neural network. Okay, this is one introductory kind of a explanation on why ANN or what is the motivation. Why ANN is because human brain has certain smart capabilities like the feature extraction, and it is worth imitating that to do some problem solving. That is why ANN. Okay, any questions at this point? Okay, some of you may have some backgrounds in neural networks. If you have some more points or would like to ask some specific questions, please do that. By that time, I will take another stuff from another, Okay, any questions? Any questions? Malabar is very silent. I don't know why. Okay, anyway, if those things were very simple, this is therefore a comparison. Computers versus neural networks. Our standard computer usually have one CPU. We know the von Neumann architecture of a computer: input device, CPU, memory, output device, etc. You know that very famous or notorious block diagram of a computer. So it has only one CPU. But in modern computing system, you know, there is a concept of co-processor, etc. But basically, a computer is treated as a one CPU system. But a neural network, either biological or the artificial neural network, which we are going to design, is a highly parallel processing system. I was telling you, because billions of neurons are there. So it is a one CPU system, only one processing element. The CPU is the processing element. But in a neural network situation, all of them are individually processing elements. So it is a highly parallel system. When one CPU is there, it is very fast. We know that the problem of multiplying or dividing or doing some computation like this, the computer is very fast. But because of more people involved, definitely it is slow. Then this is very important. The third one is very important. In a conventional CPU, there is only one, of course, there is only one CPU. It should be highly reliable. Suppose you are going to the computer lab and you are turning on the system. If nothing is coming in the display, what you will do? CPU may be facing difficulties. You will try to strike the computer from one side, hit it from the other side also. Nothing is happening. You may report the same to the system analyst and go for tea. That is the only solution. Because one CPU, if it fails, the entire system fails. But you know, in a neural network system where thousands and billions of neurons are there, unreliable units are okay. If some of the units are not working, because of many reasons, then the system will not completely fail. Rest of the people will adjust with the situation and it can work. This is just like your project group formation. That is very notorious in every college, right? You will be having 5 people. You know that some of them will only join for tea and photocopy. And even if 2 of them are very lazy, rest of the 3 will do the project. And finally, when the presentation arrives, you will claim that all of you have equally participated because you want marks for all of them. They are very favorite guys for you. And finally, teachers will believe and give you good marks. Okay. Some of the elements can be unreliable, no issues. This is basically a static infrastructure. You code the computer, move a comma b, add a comma b, it will do that. Okay, it is a static infrastructure. But a biological neuron or human brain, etc., are a dynamical kind of a system because there comes the capability of learning, understanding, etc. Because we know that humans can learn, adapt. That's another word, adapt to the situation. You know how to behave in a crowd of friends. You know how to behave in front of the HOD. He's a different person. You know how to behave in another crowd. So this adaptation capability is amazingly good characteristics for the human brain. So it's a dynamic infrastructure, but computer is not that type of a system. Therefore, in the conventional computing, we have the concept of programming in any language or in any assembly programming structure, etc. But when it comes to neural network situation, this new word arises: learning and training. Both are possible. You can learn. Somebody like the teacher can train you. So both are possible for human brain. Therefore, that may be possible for the ANN also, which we are going to develop. So this is the immediate comparison of the 2 types of computing system. One is standard computer, one is neural network system. Biological neural network system is the real thing. Artificial neural network system is the one thing that we are going to develop with the inspiration from the biological side. Any questions at this point of time? If you have something, or even if you don't have something, it is better to ask. Okay, some things are there in the chat. Computation power of computer is strong, but no thinking capabilities. Correct. That is part of learning. What Kritik says is good, a point. Nanda Kishore is saying is it possible to transfer human consciousness to computer by replicating our neural network? As of now, it looks like, again, a mission impossible because I don't know whether we could bypass the God. The human brain structure is very complex. You cannot completely imitate it. You can be maximum Kottayam Nazir, right, in imitating. He's doing a good job, but you cannot be the real. Therefore, what I think, of course, that's why at the beginning I was talking to you about smart computers, smart devices, decision making, and AI, etc. Driverless car. Machines are talking to each other and taking decisions. So I don't know whether machines are going to override people. Okay, you have seen in English films about robots, defeating human beings, etc., etc. But as of now, the complete dynamics and functionalities of human brain cannot be imitated. That is what we are. We could understand. Of course, you can always try to narrow down the boundary between human and machine. Okay, that is actually AI and other kind of things are doing. But I don't think that never the machines will bypass us. So that's a general thought process. Okay, any other questions? If you could turn on your mic, that is better.
Sir, can I ask you one question?
Yeah, definitely. Please, if you could say your good name, that is very interesting for me. If you could share, tell me your name and then.
I'm Srijit. I'm.
Okay, okay, Srijit.
I'm Srijit.
Yes.
Sir, can we relate neural networks with the WSN where we can adopt ad hoc networking, something related to this one neural network? All the nodes may or may not be present at the same time, something like that?
Somewhat, generally. Okay, there is nothing wrong in correlating them. Not exactly, but okay, to some extent we can say that. And of course, we will continue this point when we try to discuss some of the structures of the artificial neural network, which is immediately coming up. Then I think you may be better correlating. But as of now, it is somewhat a weak yes, is my answer.
Okay, thank you.
Thank you. Anybody else? So I request people to add stories so that it may not turn one-sided, kind of a horror. Okay, anyway, nothing very complex has been explained so far. Therefore, don't ask me too much of questions. This is copied from biological textbook. This is the structure of a single neuron. Single neuron, biological neuron inside the human brain. Thing is very simple. We will make it simple like this. This is it. This is the structure. It looks like a dragon, right? Chinese. Okay, a single neuron. A single neuron means these things, these things which I am marking here, they are actually called dendrites. This is the thing, dendrites. They are actually receiving units. Okay, understand it like that. Then there is a center portion, this circle, that is actually called the nucleus of the neuron. Then, of course, another set of connections. See, this is actually called, the end of this is called synapses. Synapses. This is synapses. Biological terms, don't ask me questions. These are all dendrites. Right? Synapses are output nodes and dendrites are input nodes in the biological neuron. Now the story is like this. Human brain consists of billions of neurons. A single neuron may look, not may, it is like this. This is the biology knowledge. What is happening basically is, when thousands of neurons are interconnected like this, or billions of neurons are interconnected like this, actually what is happening is the signal or the system which is propagating through these neurons are in the form of very small voltage spikes, very small voltage spikes in the microvolt range or something, spikes. That means the dendrites can receive signals in microvolts from other neurons or sometimes even from outside world. So they all will be receiving, or if they are connected, they will be receiving signals. Signal actually means voltage by other neurons, and all of them will be collected over here because it looks like a summing kind of a system. And you know, in the nucleus, all the voltages will be summed up and some kind of activity will happen inside the nucleus that is called neuron activity. Then the output will be delivered through the synapses. It almost resembles 2-3 things for an electronics or electrical engineer. Some people may try to recollect the summing amplifier, etc., that they are studying. So many inputs and one output. This is the summing amplifier. Okay, I'm not drawing the complete circuit of the operational amplifier, etc. But you know that systems are there where you can give adder circuits or summing amplifier, etc. Some others may try to correlate this with the gate system, where there can be any number of input, N1, etc., NP, then of course the output. All these generally looks like multiple input, single output kind of system. The neuron is also somewhat like that. Many inputs through which it can receive signals, one nucleus, okay, some center portion where something is happening, and then the output. And in a gate, etc., this output can be connected to other gates. But there is a problem. You cannot connect it to infinite number of other gates. There is a limitation called fan out in digital systems. Okay, I'm not going to fan out what it is, etc. I generally assume that you know it. Anyway, you cannot feed infinite number of gates because current and voltages, etc., need to be supplied or received, etc. So fan out. But you know, in a biological neuron, theoretically, there is nothing like a fan out. This voltage can be connected to any number of other neurons. See, for example, here it is connected to another neuron. Here it is connected to another neuron. Here it can be connected to other neuron, etc., etc. The dendrites of other neurons. So the dendrites will receive signals, nucleus will and summarize and process the signal. Output is delivered through the synapses, and from there it can be connected to other neurons. Therefore, the process of learning or storing knowledge, etc., happens because of the interconnection of neurons like this. This is one point. Second point is, we exactly don't know what is happening inside the nucleus. All other things are somewhat clear to biological scientists as well, but they don't know, even they don't know what is exactly happening with the nucleus. What is the actual process happening over there? But they know that they are receiving signals in voltage form, spikes, processing it, and the output. What processing exactly is happening is not known. Only God knows it. That is why the previous question I answered a week. Then, if we don't know something, engineers have a usual escapism kind of an approach. What we will do is, if we don't know what is happening, we say that, okay, something non-linear is happening and output is produced. We use the same trick here also. We know all other things. Input is supplied, input is received, then it is processed, output is produced. But what process is not known to us. So the process basically, if we don't know, we say that it is something non-linear kind of an operation. Therefore, we may say that inputs will be coming into a neuron, inputs will be coming to a neuron. Some non-linear things will happen inside because we don't know what it is. That is why then output is delivered. This is what is the concept of neurons. And you know, if the net input, suppose these are V1, V2, etc., say Vn voltages. If you add them together, sigma Vi, if you take I is 1 to n, etc., then you know a considerable output will be produced by a single neuron only if this net to input voltage V net is greater than some threshold Vt. Then only considerable output will be produced in a neuron. That is also observed by biological scientists. And if the net input voltage to a system, a neuron, a single neuron, is larger than the threshold minimum voltage required for its operation, then output will be produced. And when output is produced like this, we may say that the neuron is fired. That is the interesting word they are using. The neuron is fired. Fired means it produces output, or excited. It will be excited or fired only if the net input voltage to the system is larger than the threshold voltage. So this is what we generally know about the neurons. And you know, the interconnection between one neuron and other neurons, like synapse of this neuron will be connected to dendrite of the next neuron, And you know, some biological membrane will be formed in between the dendrite of this second neuron and the synapse of the first neuron. And these membranes are called synaptic connections. They are called terminal and synaptic connections. See, this in between and dendrite, something is formed. It's called synaptic connections. So the synaptic connections are basically responsible for making the signal flow between the neurons. So these are the general points regarding a biological neuron. With this knowledge in hand, we will now try to develop an artificial model for this system, and we call it an artificial neuron. This is a single neuron. Billions of such neurons will be connected. So the important terms are dendrite, input side, synapse, output side, synaptic connections, interconnection between neurons, cell of the neuron, center of the or nucleus of the neuron, non-linear processing because we don't know the story there, firing, threshold, etc. Any questions? This is biological neuron. Now we will, and when you learn something, what biological scientists are saying is that when you learn something, what happens is a kind of relationship will be formed in between the dendrites and synapses of neurons. And the knowledge is actually embedded in the human brain in the form of synaptic connections. That is what biology says. And again, they are saying that if you learn something like things like poems or poetry, some part of the human brain will be activated. If you learn something very complex like the Fourier transform theory, some other part of the human brain will be activated. There, some neurons will enter connection and knowledge will be embedded over there. Over a period of time, even if some of the neurons dies, it happens on a daily basis. Thousands of neurons are decaying. That is why you are remembering the poems you studied in the 5th standard, even now. If you get 2-3 lines, rest of the things will come automatically. It is just like you train a nursery kid for a poem competition. And when he's pushed on the stage and starts singing, suppose he is forgetting it in between. If you encourage him to continue, he may not be able to do that. But if you encourage him to start from the very beginning, the second stretch it will go, it will continue to the end. Is it? So amazing properties of human brain. Okay, this is my thought process on human biological neuron. Any questions? Otherwise, we will, with this motivation, we will move on to develop an artificial model for the neuron. Any questions at this point? Or otherwise, if things are somewhat clear, you can give me a green signal. Okay, we can continue or something like that. If it is, it's okay for you.
Yes, sir, we can continue.
Oh, yes, of course. Then I need to copy something from the other side. Let me do that. So this is a sort of cut and paste, which has become our very favorite business. No, this is it. This is actually an artificial neuron or a mathematical model of a neuron. Biological neuron is this one. Now this is a mathematical model which can be modeled and implemented in a computer. See, these are all incoming. They are all therefore dendrites. So these connections are actually dendrites. Dendrites of the biological neuron. This is the output line you could see. This output line is therefore the axon. It is called axon or synaptic end. Axon. Dendrites and axon. It's output side. This is output side. And interesting points are, you can see these are our interconnections. Voltages from other neurons, V1, V2, say, etc., Vn, because it's not 3, any number of inputs can be there, are coming in like this, V1, V2, V3, etc., are coming in this, and 5.2, 23.1, minus 3.4. This is actually representing the synaptic connectivity. The connection between neurons are represented here with what is called synaptic weight. So it is a synaptic weight, in fact. Synaptic weight actually means these V1, V2, etc., Vn are coming from other neurons. So this 5.2, it is just like a signal flow graph in control system or anywhere else. This 5.2 represents the strength of interconnection between this neuron. Say this is the jth neuron. We are considering a jth neuron. This jth neuron with the neuron who is supplying this voltage V1. So 23.1 is the strength of interconnection between jth neuron, the jth neuron which we are considering, and the neuron supplying the voltage V2, like that. So the point is, any arbitrary neuron J, any neuron, do not have the same kind of relationship with other neurons. For example, V1 and the neuron providing V1 and this neuron has a interconnection strength of 5.2. It's just like your friends in the department. Then this neuron and the other neuron, V2 neuron, the interconnection strength is 3.1. This is very close friend, boyfriend or girlfriend or something like we can't live without kind of a situation. Okay, that is a very strong relationship. Then this is minus 3.4. Enemies are also there in the department, right? So this represents all these things. I mean, the connection that a neuron is establishing with other neurons may vary in its nature. And all these, even though I said it in a funny way, all these represents a kind of knowledge stored in the form of synaptic weight. This may have a meaning later on. But as of now, we can say that the kind of relationship is different with different neurons, or the strength of relationship is different for different neurons. Therefore, what finally happens over here is V1 into 5.2 plus, V2 into 23.1 plus, Vn into minus 3.4 is actually the, here V1, V2, V3, etc. With 111, this summation may arise, I think. But otherwise, it is V1 into 5.2 plus V2, okay, V2 into 23.1 plus Vn into minus 3.4. So that is why I am saying that this is the net input, the sum to the nucleus. This should be, the entire struct should be greater than V threshold, then all the neuron will be get activated or fired. Then the output is produced. The problem here is, we don't know what exactly is happening in the nucleus. Then what is the relationship between all these things and the output is the question. Okay, I will come to that. I was telling you that we assume that something non-linear is happening. That is our statement, engineering statement. Something non-linear is happening because we don't know and output is produced. Okay, I will tell you what is the meaning of that non-linear operation and how we mathematically represent it and how the output is produced. But anyway, tell me whether this story of developing a crude model of the biological neuron is clear to all of you. This is a single neuron, single artificial neuron. Any questions? Okay, something is okay, it's okay. Any questions if you have, please tell me. By that time, I will try to get another picture for you. Please think about all the things we were talking about. And if you have a question, please have it now. Is it clear so that I can proceed? Again, everybody looks very silent.
Yes, sir, you can proceed.
Very good. Thank you very much for assisting me and encouraging me. So this is some more very sophisticated drawing. Same thing, but in a some more better way. See here, this is the model of a single neuron. Remember that it is a single neuron. Artificial neural network is going to be an interaction of many neurons of this kind. That is the story. Therefore, this is the picture. This X0 is equal to 1 and this weight equal to BK. Synaptic weight equal to BK is a fixed input. You can see that it is not coming from any other neurons. It is part of the structure. So X0 into BK is always there. X1, X2, etc. up to XM are coming from either other neurons or from outside. It can be in both ways. And this is a summing unit and VK is the summary. VK is therefore equal to 0 to M. This is 0 to M. WKJ XJ or W into X generally. So X0 into WK0. WK0 is permanently given as BK. Therefore, this BK into that X0 is always there. It is fixed. But X1, X2, etc. we don't know. It is coming from other neurons. So that may vary from time to time. These weights are also decided. Then actually what is happening is, what is the net input? X0 into W0 or BK, X1 into W1, if I am dropping that K for convenience, X2 into W2 plus XM into W1. Everything will come into picture. And what is output? This is output. Output is equal to this phi operated on VK because VK is the net input. Actually, you know, this BK into X0 Vk into X0 is actually representing, it resembles our V threshold, in fact. So this is a positive quantity. Some of these can be negative, even the weights or the inputs that you have seen in the last picture. Some of them can be negative. So if you add all of them together, if it is just positive or just larger than this BKX0, then only neuron will get fired. So that is the actual meaning of this fixed input. Fixed input represents threshold. And you know, in some literature, they are doing without this fixed biasing input or the threshold input also. It can also be part from the outside world. That way also it can be modeled, no issues. But anyway, this is the general structure. And this is very important. Yk is equal to phi operated on Vk. So the argument or the operand of this function is Vk, that is the net input to the neuron, including the fixed input. And this phi is actually a non-linear mathematical function. Non-linear function it is. I will tell you what it is. For example, suppose you have output y and input x, and the relationship is equal to y is equal to mx or even mx plus c. You know that it is the relationship of a straight line. It's the equation of a straight line. So if you start drawing when x is 0, it is c. When x is 0, the output is c. Like that, it is straight because when x increases, y also increases. This is a linear relationship, but we will not use this kind of functions. Rather, we use non-linear functions. That means the relationship between the net input, here it is Vk, and the output Yk will be non-linear in its behavior. I will show you examples which will make things very clear. Okay, at least tell me whether the structure of a single neuron is somewhat clear to all of you. If you have a question on that, I am ready for a pause because it was almost one way throughout. If you have a question, please tell me on how we arrive at the mathematical model of a single neuron. This is the mathematical model of a single neuron. Everything else is okay, but good biological neuron, except the this thing, because of our lack of knowledge, we are saying that it is a non-linear function. That's the only way out. Okay, is it clear? Is it clear? Any questions? Don't keep anything in your mind.
Sir,
if you ask, yes, please.
Sir, is it possible to give two threshold
Yes.
values to a single?
Generally, no, because usually this will be fixed. You can decide on the amount of this value, but you cannot have two different values. For different neurons, you can have different biasing values. All the neurons need not be clones of other neurons, but for a single neuron, we cannot accommodate.
Also, the activation function
Is it
cannot
clear?
be changed at any. If we assume the inputs as you said to XM, and is it possible to change the function at any time of the like in between the
Activation
operations?
function.
Is it possible functions?
No. Usually we don't do that because that big unimaginable. Generally, these things will be very much fixed before we process the training or before we start the number of neurons, etc., will be finalized. Activation functions also will be
Okay.
So that's the general situation. The only dynamical parameter in a neuron or a neural network is the weight only. You can change only the weights in between. Inputs, we don't know what is coming up. Only dynamical parameter in a neural network after the structure, etc., are finalized is or are the synaptic weights.
Okay.
All of this.
Okay, sir. Clear.
Okay.
Okay, sir.
Anything else? Okay, then we will continue. This is a typical example of activation functions. Let me try to introduce this activation function, which is called step function. This IN, in fact, is actually the net input. So we may use that VK here. VK is actually here. Output will be equal to 1 if input, that is VK, is greater than 0, equal to 0 if input is less than 0. This is a highly nonlinear function. Even if input is just greater than 0, output is 1. So it doesn't matter whether the input is 0.5, 1, 2, or even infinity. Only thing is, if it is greater than 0, output is 1. If it is smaller than 0, output is 0. This is a typical function. The output is not linearly either increasing or decreasing with respect to the input. So this is a typical example of a nonlinear, activation, nonlinear activation function. Sorry, nonlinear activation function. And this is called the step function or limiter. It is called limiter or step function because this is the step function 0, 1. The second one is called sign function. It is also called a double limiter, double-sided limiter, because instead of 0, the output will be -1 if the input is less than 0. That is the only difference. So the bipolar limiter. It is also called bipolar or two-sided limiter. Bipolar limiter. Another activation function is sigmoidal or sigmoid function. Some people call it sigmoidal. It is like this. I will get you an explanation on this to get it more clear. Okay, let me again copy one stuff. More clear picture on what it is. A more clear picture on what it is can be given to you. Okay, where is it? Okay. So this is bipolar. This is the equation of the sigmoidal function. 1 by 1 plus e raised to, I will write it here, 1 by 1 plus e raised to minus alpha into is the, and simplicity alpha equal to 1. Then it is 1 by 1 plus e raised to minus vk. What happens is, when vk is positive infinity, 1 by 1 plus e raised to minus infinity, that is equal to 1 by 1 plus 1 by e raised to infinity. E raised to minus infinity is 1 by e raised to infinity. So this portion becomes 0. Actually, it is 1 by 1. That means when the input tends to infinity, output only reaches at 1. And when the input go to negative infinity, it becomes e raised to minus alpha, then a minus vk into minus, then it become positive. Then it become 1 by 1 plus e raised to infinity. That means 1 by e raised to infinity is infinity, 1 plus infinity is infinity, 1 by 1 infinity is 0, nearly 0. So when the input moves towards minus infinity, output reaches 0. When the input moves towards plus infinity, output reaches 1. So this example activation factor. And depending on the value of alpha, the slope will change. The slope will change. The expression will be only from 1 to 0, between 1 and 0. And if you modify the equation to this second one, then become double-headed kind of a sigmoidal. The play will be between plus 1 and minus 1. So that is the only thing. All of them are therefore non-linear activation functions. My point is, the first two are also known as discrete activation functions. Discrete, because the output is either abrupt, 1 or minus 1. But the last one which I have demonstrated, this one is a continuous activation function, because output is not abrupt, but it's a continuous quantity, but it will never cross the boundaries 1 and minus 1. The relationship is not linear. With infinite, it will reach 1. So that means it is not a linear relationship. So these are typical examples. Many, n number of such activations in practice, But these are the popular nonlinear activation functions. With this, the story of the artificial neuron model is somewhat complete. We are imitating the human brain neuron with these weights, receiving input, summarizing, operating them in an activation function, and delivering the output. And interestingly, the activation functions in many ANN literature, if you read, some people call it skewing function. Skewing means however large they may be, output will be finally skewed down to between 1 and -1. Everything will be skewed down. Skewing function, it is called. And some people called it limiting function because the input, whatever large the input value, the output will be only between 1 and -1 maximally in any of the activation functions. So skewing function, nonlinear function, activation function, limiting function, all these are synonyms of the same kind. I mean, of the same nonlinear function. Is it clear? Any questions? Again, a pause. I am looking into my clock and not trying to bore you too much. Okay, some more time, 10 to 15 minutes maximum, I think. Okay, any questions at this point on how we are developing a neuron model? And with this, we can definitely move to develop a neural network. With these neurons interconnected in a systematic way, it is called a neural network. Any questions? Or is it somewhat clear? Yes. Again, it looks like a huge silence. I don't know why.
Hello, sir. One thing.
Yes.
Sir,
Yes,
actually,
please.
y is equal to mx plus c. So y can we write this as y1 is equal to m into h1 plus by checking? So it will be a non-linear like that.
I didn't exactly get it. Can you please repeat that?
That is y is equal to mx plus c. It's a
Y is equal to, okay.
Yeah. So we are telling that it is a linear function, right?
Correct.
Sir, actually, from the graph, it is a straight line only, so no problem. But in signals and systems, we are checking like that y1 is equal to m into h1 plus c, y2 is equal to m into h2 plus c, like that. So, principle of superposition and homogeneity like that, it will hold only if y1 plus y2 is equal to m into h1 plus h2. But here it is not possible, right?
Okay, when you check system, then that is called that y is equal to mx plus c stuff is called your bias. Somebody else is trying to speak, I think. Okay, if you're not I'm involved in the discussion, please turn off the mic. Okay, anyway, in that case, because of that bias, actually in electrical systems, signals and system, that bias is basically called a DC offset. Such systems will be non-linear.
Hello, sir. Hello.
You are talking about a system in which output is equal to AX plus B kind of a system, isn't it?
Yes, sir. Yes, sir. So y is equal to mx is linear and y is equal to mx plus c is non-linear, like that. Is it true?
If C is a constant, it is definitely the equation of a straight line. Okay, to avoid confusion and even to save time, you forget about C then. You just have y is equal to mx. Okay, I can of course discuss this. Okay, we may not waste much of the time on that. This is something different. This bias, if it is there, the system becomes non-linear. Your superposition will not work out there. Yeah, one x1 plus b1. If you see, it is non-linear. I do admit that. Okay, then to avoid the confusion, you just treat y is equal to mx. That is a straight line, at least, right?
Yes, sir. Yes, sir. Okay.
Okay. Now, having said this about the model of neuron, okay, we don't have much time also. Let us now see what the neuron can basically do for us. I will try to demonstrate as an interesting problem like this now. Okay, don't worry about this. This looks very simple only. And let me therefore, 1 minute. So this is a particular demonstration, a very simple demonstration of the capability of a single neuron. Capability of a single neuron. What a neuron can basically do for this. Look into this, the second diagram. This is second. This looks like the first diagram. Okay, look into the second picture, which is basically a neuron. See, x1, x2 are inputs coming in. x0 into w is bias. That is therefore 1 into -1. So it is always -1 coming in, fixed. x1, x2 coming from outside. Summer, activation function, output. So typically this is a neuron. Now keep it there. Now a second point, not related to this. Come back to the first one. What is demonstrated here is 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. Can you tell me what it is from your electronics knowledge? 0, 0, 0, 1, 1, 0, 1, 1. This truth table represents what?
OR function.
Simply OR function, isn't it? The output will be 1 when at least one input is high, 0, 1, 1, 0, 1, 1. Otherwise, the output is 0. This is basically OR function, which is very simple and people can understand. But I am interpreting this as a pattern recognition problem, where x1, x2 are treated as 2 pixels, 0 as black and 1 as white. Then it is 0, 0, both dark, 0, 1, 1, 0, 1, 1. And whenever the output is 0, I call it that as class 1. And when output is 1, okay, I'll call it class, class 1. And when output is 1, I call it class 2. That means these are patterns. 0, 0 is a pattern, 0, 1 is a pattern, 1, 0 and 1, 1. All of them are patterns. And some patterns belongs to class C1. Some other patterns belongs to class C2. Only 2 classes. So this is a pattern classification problem. And it is very simple also. A pattern will belong to the class C2 if at least one bright spot is there, at least one is there. That you can very easily understand from this. And if all the pixels are dark, it belongs to class C1. So this is the this is how we are interpreting the OR problem as a pattern classification problem. Therefore, what happens is x1, x2 combination is treated as input and y is treated as the output. So the output is basically telling us whether a given pattern belongs to class C1 or class C2. And you know, that is now demonstrated in a x1, x2 plane. X1, this is x2, x1, x2, x1, 0, 0 is this point. This is 1, this is actually 1, 0. Okay, this is actually 0, 0. This is both 1, 1 because x1 is 1, x2 is also 1. This is 0, 1. x1 is 0. You can mark the patterns in the x1, x2 plane. So usually teachers will explain this 2 input problem only, because when it is 3 input, it is very difficult to draw this. So that can be an assignment, I think. Anyway, this is how we represent the pattern classification problem. And this stars means they belongs to C2. They are all same class. But this red circle represents another class. And we know that it belongs to class C1. It is clear. And the point here is, in the x1, x2 plane, the 2 classes can be separated using a straight line. And therefore, these patterns are called linearly separable patterns. That is one thing. Linearly separable patterns. Because it is possible to draw a straight line between the classes, say C2 and C1. This is C2 and C1. Now, This is a pattern recognition problem. We are now trying to make use of a neuron to do this task. For example, the activation function is pre-designed as limiter, single-sided limiter. That means output is 1 when net input is larger than 0. Output is 0 when net input is smaller than 0. Here you can see the weights are +2. This is +2. This also is +2. The fixed one is -1. Now suppose you are feeding 0, 0 to the system. 0 into 2 plus 0 into 2 minus 1. The net input to the activation function is -1. F -1. Can you tell me what will be the output? Anybody? X1 into W1 plus X2 into, that is what the neuron is doing. Then this bias will be added. It is put to the activation function. Then output is produced. So what will be the output? Is it that complex? Anybody? Or if it is not clear, please tell me. Suraj sir, what is our time to conclude?
Yes, sir. Like, you can continue, sir.
Okay, for some more time. So
Yes.
give me red signals when it is overheated, okay?
-1. Okay.
What's the output? Anybody? This is just interesting. Nothing like Fourier transform. Very simple only. X1, X2 is fed 0, 0. 0 into 2. Whatever synaptic weight into input is going into the nucleus. Can you tell me what is the output? Okay, something. Okay.
-1 is
one output is
-1.
if it is -1, if it is a double-sided limiter. In this case, we are assuming that it is a single-sided limiter. This thing only, the single-sided first one. Then output is playing between 1 and 0 only. So in that case, here the output will be 0.
Okay.
So what happens when 0, 1 is fed? Can somebody assume 0 into 2 plus 1 into 2 minus 1. So 2 minus 1. So the net input is 1. F1 is equal to what? Limiter. If the net input, the argument is greater than 0, output will be 1. So what will be f of 1? Anybody? Yeah, it is simply 1. Scikit-learn says it as 1. And for 1, 1, definitely 1 into 2 plus 1 into 2. 2 plus 2, 4 minus 1, 3. F3. F3 is also 1. That is why it is non-linear. Even if the net input is 1 or 2 or 3 or infinity, output is 1 only. So F3 is equal to 1. So what I'm trying to tell you now is the single neuron can do the classification problem for us. The single neuron can do the classification problem for us. And you know, actually the weight values are responsible for solving the problem. These weights are actually embedding the knowledge of this problem solving. Therefore, an important conclusion or point is the weights in a neuron or in a neural network, when more of them are interconnected, will actually represent the knowledge. If you change these weight values, sometimes AND function could be implemented. AND means output will be 1 only for 1, 1. For all other combinations, output will be 0. So weight is actually responsible because the activation function, fixed bias, etc. are finalized. Then the only thing you can change is the weights. So if you change the weight, definitely you can change the type of operation. This is what is happening during training or learning in neural network. Training or learning in a neural network means arriving at appropriate weight values to solve the problem in hand. That's all. So this is what we are trying to basically do in INN. Thing is, in a practical situation, we will be having more than one neuron interconnected in a systematic fashion to solve the problem. But anyway, using a single neuron, now you have classified or gone for the pattern recognition problem called OR problem. Is it clear? Is it clear? Any questions at this point of time? If you have a question, please tell me. Or otherwise, is it clear? Now, your WhatsApp messages if possible. This is another classification problem. Thing is, here also it should be X1, X2. This is called the Xor problem. Xor problem is 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, but 1, 1 also is 0. Here 1, 1 was 1. So therefore, this belongs to say C1. This belongs to C2, but the last one is also belonging to C1. This is also a two-class problem. Two classes are only there, but the patterns are different. And if you mark it, this is 0, 0, this is 1, 0, this is 1, 1, this is 0, 1. And the problem here is you cannot draw a straight line between the two classes because this belongs to C1, this also belongs to C1, but the other two patterns is, this one belongs to C2 and also belongs to C2. You cannot anywhere draw a straight line between them. Only possibilities are, okay, this is one class, and if you want to separate them, these are the only possibilities. One possibility. Two classes are not linearly separable or linearly inseparable classes. Okay, anyway, I'm just trying to demonstrate to you the difference between this classification and this classification. Now my question is, can you propose a similar kind of a neural network, for example, this kind, this kind of a system, where we can, I think, copy this. Okay. Okay. My question is, this was your solution for all problem. Now my question is, can you randomly, because we don't know any methods as of now, some weight values, W1, W2, and the bias value, so that Xor problem is solved? It is simple because only thing is you should achieve like this, something like this, Xor problem. And the weight values can be anything, full numbers or fractional numbers like 2.3, 1, whatever may be. The only complex numbers may not be allowed. Any number, fractional numbers, a small number, large number, no issue. Any value for the weight, any value for the bias also, or you can eliminate that also. Only thing is, this should be satisfied. When 0, 0 is given, 0 should be the output, 0, 1, 1 should be the output, like that. Can you, with some trial and error, find out a set of weights and bias values to solve the Xor problem? Is it possible? Can somebody suggest it? But we may not randomly do it in practical situation. We will have mathematical approaches, but we can formally find out ways. It is actually called training in neural network or learning in neural network. Anybody? Any suggestions? Random values. These two are 2, 2 and minus 1. You Xor problem itself can be solved with different weight values. There is no unique solution. I put +2 and -1, it is working. Some others can find out different weight values for OR problem itself. No issues. No unique solution. Multiple solutions are possible. But no problem is to find out weight values to accommodate the Xor problem. Any suggestions coming into anybody's mind? Any values emerging? Sometimes randomly, if you think, sometimes it may work, sometimes it may not. Any suggestions? Any suggestions coming in? Yes, somebody is trying to speak. Is it to me or something happening at home? Because online classes means we will be listening to secrets as well, right? Discussions happening at home.
Sir, can I have one activation
yes.
function like this? That is, if the value of the function is like this, that is greater than for the input greater than equal to 2, and like that it is a positive. 1 is giving output, and if the function is less than or equal to -2, also the output is giving 1. So that we can have the bias as W1 equal to 1, W2 equal to 1. So the input correspondings are 0, 0, 0 into 0 into 1.
Then there is a problem. That's some kind of an area where you don't have an answer on what is the output, isn't it? If it is greater than 2 or less than -2, it
yes,
is greater than 2 or less than -2, it will work. But what is the situation between -2 and 2 is the problem.
Between -2 and the output is 0. So I am defining function like that. We can have like that and all.
No, because this is a 2-class problem. Therefore, the output can only assume 2 values, 1 and 0, or 1 and -1, not
yes,
3 values.
Only, sir, 1 and 0 only is output value will be coming within the range of -2 to 2. It is coming to 0, and beyond 2 and beyond -2, it is having the value of 1. But I am forming an equation like that. That is W1 and W2 weights are set to 1 value. W1 is equal to W2 is equal to 1, and W0 that is I am making to -2.
-2.
Not
okay, please.
Not -2, just 1 also, and accordingly I am shifting my region so that I will get 2 outputs, right?
That is not accepted, because there comes a dead zone kind of a thing. Of course, your thought process is highly appreciated, but you know, when we go for a real situation, slightly corrupted data should also be processed here. So if it is not exactly 0, instead of 0, some other values are coming in nearby, then also the system should solve. And this kind of conditions putting it is not a purely mathematically nonlinear function. It has discontinuities. That is not accepted. And you know, the final comment here is, okay, if you have enough time, I can tell you more on this. But anyway, let me try to conclude for the benefit of others also. You know, for a single neuron like this, using conventional nonlinear activation function, it is a mission impossible to separate or find out weight values and bias values such that Xor problem is solved. It cannot be done. It is not possible for a single neuron to solve an Xor problem with the accepted kind of nonlinear activation functions. So whatever function otherwise we design will have a dead zone or discontinuity, we would like to say. That is not accepted. Therefore, what we do is we will go to what is called, this is a typical example, what is called a neural network. Okay, I'm not bypassing you. I am interested in continuing your discussion. I request you to keep on discussing after this class. Who was projecting this? Can you please tell me your name?
Sir, Rahul.
Rahul, we will continue the discussion, because otherwise it will steal the time of all others also. Your thought process is good, but that activation function cannot be accepted. I can tell you the reasons also. Third thing is that's all, and one thing is discontinuity. Therefore, the mathematical conclusion is that nonlinear classification problems or nearly inseparable classification problems cannot be done with a single neuron. Therefore, we go for interconnection of neurons. For example, this kind of a system can solve your Xor problem. This is a typical example where we have a formal structure now, and the blue circles are called input layer neurons. These are called hidden layer neurons, and this one is called the output layer neuron. This is actually called input hidden output layer structure, which is very popular, and this is called a 3-layer neural network. And you know, these are the paths through which inputs are entered in X1, X2. ABR neurons, fully fledged neurons, will process the signal, and you know, all the neurons of the input layer are connected to all other neurons in front of it or in the hidden layer. And therefore, this connection is actually called a feed-forward connection, also called fully feed-forward neural network, because the outputs of all the neurons are connected to all the neurons in front of it. And the questions are, how many neurons should be there in the input layer, hidden layer, output layer, etc. So many questions are possible on that. It is not equal, but in this particular problem, it is accidentally became equal number of neurons in input layer and hidden. But actually, the number of neurons in the input layer, neurons in the hidden layer, and even the neurons in the output layer are problem dependent. And because of the constraint, because I need to stop at 7 o'clock, I'm doing like this, because many of the secrets have not been revealed. But anyway, please understand, you can see how many weight values. These are actually arrived at after a long training, after feeding the input and training. Training means adjusting the weights. We will adjust the weights many times such that finally the outputs will be correct. That is actually called training the neural network. So thing is, basically, inside the computer, what remains as a neural network is not something like our electrical network, only some weight matrices. This is the input matrix, this is the output matrix. And this X1 will be, and of course, this will be sometimes no weight will be there, only input is fed. And suppose the output is A0, this is B0, or A and B. Enough. A into this W A, suppose this is the neuron C and D. Therefore, this WAC, this is WAD, etc. All these are weight multiplications. If you write A and B as a matrix, and all these weight WAC, WAD, etc. properly, rows and columns should be correct. Actually, it is matrix multiplication, then activation function, and the output is delivered. So this is actually in a very simple manner happening in a neural network. So because of time limitations, I would like to wind up with this. Only point is, a single neuron is not capable of doing too many things, too many smart problem solving. It has limitations. It has some capacity, but limitations as well. Therefore, we will move to neural network. Neural network approach is input hidden output layer. So many special kinds of neural networks are also there. And arriving at the final weights is called training or learning in the neural network. After the training process is completed, we will make everything static. We will not change any weights. We will not change any activation functions. We only feed the input and see what is output. Okay, with that, I think I should conclude. Otherwise, if I continue, I can tell you a lot of stories. It's not fair because it's almost 1.5 hours. Thank you very much. If you have some genuine questions, we will discuss it now. Wind up. This is just an introduction only. Unfortunately, we couldn't move to modeling, etc. I think we will have a separate session on some applications later, training. Okay, thank you very much. If you have a question, I'm ready to address it. Andy? I think we will move to a chatting mood where we can see each other. If maximum number of people could turn on the videos, that will be good, I think.
Thank you, sir, for this incredible session. Do anyone have any queries or feedback? Please feel free to drop it down in the chat box, or you can directly ask, sir, by unmuting yourself.
Yeah, that will be more convenient. If you have some quick queries, we can have it. So now the main query is about the dinner, right? It's almost.
Yeah, dinner.
Yeah, so virtual dinner and virtual tea is nowadays not possible. That's the challenge.
So now I would like to invite Shreya Anil, a member of IEEE SD MDIT, to deliver the vote of thanks.
Hello, is it audible?
Yes,
Very
it
much.
is.
Okay. Good evening, one and all. I'm deeply honored to propose the vote of thanks on this memorable occasion. First of all, let me thank our chief guest, Dr. M.B. Rajesh Malayekil, Associate Professor, Department of Electronics Engineering in College of Engineering, Chengannur, who despite his busy schedule has found time to share his valuable knowledge with us. We are very much delighted to be a part of this and are very much grateful to you for this informative and innovative session. I thank everyone who worked behind this and made this event fruitful. And next, let me thank all of you present here for your cooperation in making this function a resounding success. Once again, let me thank all of you who have been part of this event, and let me thank IEEE Malabar section for giving us an opportunity to conduct a fruitful event. Before we conclude our event, let us have a photo session. For that, all of you, please kindly turn on your cameras.
Yes, Nata Kishore is compensating for my problem of hair, right? Very good.
So I hope everyone turned your cameras on. So on countdown 3, say IEEE. 1, 2, 3, IEEE.
IEEE.
Okay, thank you everyone. So now our webinar session is over and everyone can leave. Thank you so much.
Thank you once again, Suraj
Thank you,
and
sir.
Sabit and all of us.
Thank you, sir. Thank you.